Okay, we're going to start notes over the Scientific Revolution, Chapter 22, Section 1. Okay, up to this point, we've been talking about European exploration in the New World. We've been talking about trade between the Americas and Europe. And now we're going to kind of switch gears and we're going to talk about new thought and new ideas that were circulating during this time. Before the Scientific Revolution, scientific view came from ancient Greek philosophers, Aristotle, Plato, the works of those ancient Greek thinkers, or it came from the Bible. As we well know, in the European church, the Catholic Church was the basis for all scientific thought. And we well know, we learned about, and when we talked about the Middle Ages, during that time, the church was pretty much the driving force in Europe. So you can tell just how powerful the church was. Very few people questioned the philosophers or the church, so it was pretty stable scientific thought. The main theory about how the earth worked was the geocentric theory. And in the geocentric theory, the earth is a stationary, unmoving object of the center of the universe, and the planets, moon, and the sun rotate around the earth. The theory had many supporters. Aristotle came up with the idea, and the church supported it. So it was a very widely supported argument. By the 1500s, there became some debate about this idea, however. Ancient scholars started to really think and wonder if these ideas were true, and that's what sparked the scientific revolution. And the scientific revolution was just a change in European thinking, and it challenged the ideas of these ancient thinkers, and it challenged the church. So that was kind of interesting. It came about because scholars were getting brighter. People were starting to understand new ideas. They were translating Muslim works brought in from the Crusades. They were starting to uncover classical manuscripts. And people were just thinking more. We have to remember we're right after the Renaissance when people were starting to think and apply knowledge better and start to really take individuality into account. So it was just a time of more thinking. Also, they have explorers are traveling to Africa. They're traveling to other places. You have explorers who are also, they're needing scientific research for astronomy and mathematics, for navigation, for using their geographic instruments. So you're having this new need for scientific truth and scientific evidence with all of the exploration going on. Also, the printing press. The printing press helped spread these ideas. So once these new ideas came about, we have the printing press that's going to help spread these new challenging ideas and get these new ideas into the hands of the people much faster than the older traditional ways. The first thinker is this lovely gentleman right here. His name is Nicolaus Copernicus, and he was a Polish astronomer. And his theory, he came up with the heliocentric theory. And if you want to, on your book, page 546, it shows a model of the Copernican heliocentric model. And it basically is an idea that the sun is at the center of the universe and the planets and stars orbit the sun. So instead of the earth being the center of the universe, the sun is the center of the universe. Now, Copernicus could never explain why the planets orbited the way they did, or how the planets orbited, but his theory was that the sun stood at the center of the universe. He never published this work until the last year of his life because he was very fearful of persecution for his ideas by clergymen and other scholars. But his last year of his life, in 1543, he did publish his theory, and it was On the Revolutions of Heavenly Bodies. So he did end up publishing his work, but he was apprehensive about it. Copernicus's book, at first, it was causing lots of stir. People were very upset about his theories, but other scientists started to think. It influenced other scientists to kind of build on his ideas. And one of those scientists' names was Tycho Brahe. And Brahe actually decides, he goes in and he starts to produce data on this theory, but Brahe dies, and his assistant, Johann Kepler, continues his work. And Kepler basically puts mathematical laws that govern planetary motion, and he shows that the planets move in elliptical orbits around the sun. So Kepler's laws actually prove Copernicus right and comes up with a theory for how the planets move around the sun, which is an elliptical motion. And this is a model, a heliocentric model. The sun is in the center, and they are orbiting around the sun in perfect circles. Kepler's model is a little bit different. It shows the planets orbiting around the sun in an elliptical motion. Another astronomer that we're going to talk about is Galileo Galilei. And Galileo, hopefully you've heard of him before. When he was a 17-year-old student, he was watching a chandelier swing in a cathedral, and he kind of tested Aristotle's idea. Aristotle had a theory that if a pendulum actually swings at a slower rhythm as it approaches its resting place. Well, as he's watching this chandelier, as Galileo's watching the chandelier, he basically proves him wrong. He counts how fast the chandelier is moving, and he notices that the chandelier moves at the same speed as when it approaches its resting place. So he basically discovered the law of the pendulum at that time. He disproves Aristotle's law of the pendulum. Also, he finds that a falling object accelerates at a fixed and predictable rate. The legend is that Galileo stood on top of the Leaning Tower of Pisa, and he dropped objects of different weights, and all of them fell at the same time. Aristotle had a theory that heavy objects fall faster and lighter objects fall slower. But Galileo actually was able to prove that theory wrong, and it says he did it by dropping objects off of the Leaning Tower of Pisa and counting how long it took for them to reach the bottom, and that they all fell at the same rate. So he disproved Aristotle in two of his theories. Galileo actually builds his own telescope, and he's able to use it by 1609. Galileo also, he starts to publish a variety of newsletters called The Starry Messenger, which describes some wonderful observations, and it's basically his records of what he sees while he's observing space and while he's observing stars. And while these observations are kind of shattering of what some of the early thoughts were. He describes the moon's surface. As we know, the moon has lots of craters and is a very imperfect surface. And that proves Aristotle wrong, because Aristotle described the moon as being a pure, perfect substance. He supported the theories of Copernicus. Galileo was extremely a different thinker. He challenged those ideas of Aristotle. And because of that, the Catholic Church basically hindered him from continuing his thinking and his scientific research. Galileo, his findings, all of his disproving of Aristotle and all of the laws that he found in Aristotle's works that were wrong, it really started to worry the Catholic Church as well as some Protestant leaders, because his theories and his ideas went against what the church was originally teaching. So in 1616, the Catholic Church basically tells Galileo, you don't need to defend Copernicus. His ideas are wrong because it goes against the geocentric theory that the church supports. So he remains silent. He doesn't really say much, but he continues his scientific work. And in 1632, he publishes the dialogue concerning the two chief world systems. And in this, he decides he's going to support the ideas of Copernicus and Ptolemy. And Ptolemy also supported Copernican theory that the Earth is not the center of the universe. So he's showing support for Copernicus, and he is summoned to Rome to stand trial before the Inquisition of the Pope. When he gets to Rome, he basically surrenders, and he says, He kneels before the cardinals. He says, I'm guilty. I'm confessing. He renounces the ideas of Copernicus, and they put him under house arrest. Galileo dies under house arrest in 1642. However, his books and his ideas spread all throughout Europe, and his legacy lives on, and his work, people continue to build on his work. So while the church basically shut down all of his ideas and he dies in house arrest under the subject of the church, his ideas did not. The most important thing that comes out of the scientific revolution is the scientific method. You guys have heard of all the steps in the scientific method. I hope that you're using this in science. Basically, the scientific method was the ideas of all the past thinkers and how they came up with their views basically encouraged the scientific method. It was just a logical procedure for gathering data and testing data. And it's the basis for it is to identify the problem, come up with a hypothesis, observe and analyze data, and come up with a conclusion based on what you've analyzed. The men responsible for the scientific method were Francis Bacon and René Descartes. And they just developed and advanced this new approach to thinking. But they went about it in different ways. Francis Bacon was an English politician, and he was a writer. And he believed that a better understanding and a scientific view of the world would have an improvement on the lives of people. So he urged scientists to experiment and draw conclusions. And he used an experimental method. He thought that by experimenting that you could come up with conclusions and come up with data by using experiments. Descartes was a little bit different. Descartes was coined with the phrase, I think, therefore I am. And Descartes basically relied on math and logic. He believed that everything should be doubted until proved by reason. So he believed in using reason to come up with basic truths. He developed an analytical form of geometry that combined algebra and geometry, and he relied heavily on using mathematics, logic, and reasoning instead of experimentation like Bacon did. He used strict reasoning to come to basic truths. The modern scientific ideas, the modern scientific method are based on these ideas from Francis Bacon and René Descartes. So it's basically a meld of the two together. Isaac Newton, Sir Isaac Newton, hopefully you've heard of Newton's laws. If you have not, you will in physics next year. Isaac Newton was famous for bringing together scientific breakthroughs under the laws of motion. Newton, he was a student at Cambridge University. He studied mathematics, and by the time he was 24, he was certain that all physical objects were affected equally by the same forces. So he basically disapproved Aristotle's ideas that one set of laws governed the earth and another set of laws governed the universe. So as you can tell, you kind of see a trend here. These thinkers are taking these theories from ancient Greek philosophers and they're basically disproving them and saying, no, we've got new technology, we have new ideas, we have different ways of thinking. He came up with a law that linked the motion on Earth and the motion in the heavens and the law of universal gravitation. He published the Mathematical Principles of Natural Philosophy, and it was one of the most important scientific books ever written. Isaac Newton basically is credited with the physical laws of motion. So his law of gravity basically explains that the same physical laws governed motion both on Earth and the heavens. So he comes up with those gravitational laws. How did this spread? Well, the spread of science had to do with a lot of different things. At this time, the spread of the scientific revolution, you started to get more instruments, you start to get more people involved in the scientific revolution. Some of the scientific instruments that were being used, a microscope. A Dutch eyeglasses maker decided he would try to come up with his first microscope. Okay, the spread of the scientific revolution caused there to be a lot of development in new tools and new instruments and new things to help make science flourish. Some of those new instruments, a microscope was used or created, and it was created by Zacharias Janssen, and he created a microscope, and they would observe bacteria swimming, red blood cells. They discovered that maggots and grubs were merely insects. Before, they had thought that they came to life spontaneously. So, as beautiful and wonderful as that sounds to observe those under a microscope, they were able to do that and get more and more information that they didn't have before. Also, Evangelista Torricelli came up with a barometer, and a barometer is just a tool that measures atmospheric pressure and helps predict the weather. Also, another gentleman, Gabriel Fahrenheit, as you know the degrees Fahrenheit, he came up with a mercury thermometer, so a way to measure temperature with a device. Now, as you know, the Fahrenheit scale and the Celsius scale, under Celsius created another scale for the mercury thermometer. In the Celsius scale, freezing is at 0, and at the Fahrenheit scale, freezing is at 32 degrees. Some of the medical advances that were going on during this time, some of the early doctors, they studied the Greek physician Galen. But the problem with that, Galen had never actually dissected a human body before. Instead, he dissected animals. And so he kind of thought that human bodies and animal bodies were so much the same. Until a man named Andreas Vesalius comes along, and he basically disproves Galen by dissecting human corpses, and he published a book called On the Fabric of the Human Body. And it was filled with drawings of organs and bones that kind of showed that the human body was actually much different than the animal body that had been depicted before. After Vesalius, there was a doctor named William Harvey, and Harvey published On the Motion of the Heart and Blood in Animals. And in his discovery, he discovers that the heart actually works as a pump to circulate blood throughout the body and describes the function of the blood vessels. So he had more discovery on the workings of the heart. Edward Jenner, he was also a very important doctor during the time because he discovered that inoculation from cattle disease called cowpox gave permanent protection from smallpox. And as we've talked about, in the 1600s, smallpox was a huge killer among people in Europe and especially in America. So Jenner's research on smallpox and becoming a vaccine for smallpox was extremely helpful. In the chemistry world, the man named Robert Boyle, what he did is he basically pioneered, he was the first one to use the scientific method in breaking down and solving problems for chemistry. He also is considered the founder of modern chemistry. He published a book called The Skeptical Chemist, and that is not misspelling, that is the actual old spelling of chemist, The Skeptical Chemist. And in that book, he challenges Aristotle's original ideas that the world consisted of 4 elements, which is earth, air, water, and fire. He actually comes up with Boyle's law, and it explains how volume, temperature, and pressure of gas affect each other. So now when you go to chemistry, you need to ask Miss Langford about Boyle's law and find out what she knows. Another chemist, Joseph Priestley, he was able to separate one pure gas from the air, and it led to the discovery of the gas oxygen in the air. So as you can see, you have all these different scientific thinkers, and they were taking the ideas of the ancient scientific thinkers and kind of questioning them, putting them into play, and coming up with their own. Hopefully you took notes over this. I'm sorry if I went fast, but I was trying to make it under 15 minutes. Bring your notes to class and we will discuss them on Monday or Tuesday. Have a good weekend.